when we consider a keystone predator model that deals with 3 or more trophic levels, then we're talking about a trophic cascade. Now, I must mention here that if you're going to study something cool like a keystone predator, which is a great term, you also ought to have another name like trophic cascade, which is a fantastic title for your talk when you start going out there to lecture about the work that you're doing. Now, let's take a look at how this works. It's a little different than the diversity model. And the way that it works is you go first into a kelp forest. And we're going to say kelp forest has lots of diversity. Now, kelp forest, you'll see some of the video. The video is phenomenal. That talks about this, but you'll see that in here live lots of different kinds of fish, and if you read the article, you'll see there's sheep's head in there, there's Garibaldi fish, there's these fish that come to the kelp forest. The forests are held onto the bottom of the ocean by this thing called a holdfast down here, and the holdfast holds onto the rock basically at the bottom of the ocean. It could be 60 or 70 feet deep, and the kelp forest, which has these large floats on it, so I'll put some of those on there too. They're pretty amazing. These floats or bobbers that hold it up to the surface. And so when you swim in this, it's like a forest of not trees, but kelp, which is kind of amazing. Now, it's important to know that at the bottom of this is an organism called a sea urchin. And this, I'll highlight our sea urchin over here. Not the prettiest of urchins that I've drawn, but amazing organisms that sort of move slowly across the bottom of the ocean, and they're looking for things to eat. They're grazers, so they're herbivores. When they come to a holdfast, what they do is they eat that holdfast. So they will have a direct negative effect right here on the holdfast. Now, they don't eat the whole kelp, but they eat the bottom of it. When they eat the bottom of it, it breaks off here at the bottom and then can float away. And off it goes. And so if there are too many urchins feeding in a kelp forest, they can actually shave it off at the bottom, and the kelp forest will be gone, losing all of that diversity. Now, we can look at another organism here called the sea otter, and everybody loves a sea otter. They're pretty amazing. One of the things that sea otters do is they prey directly on these sea urchins. They dive down to the bottom and eat sea urchins. And because they do, they reduce the sea urchin population, which protects the kelp forest. So they have, you guessed it, an indirect positive effect on, they have it all better here, indirect positive effect on the kelp. So the presence of the otters protects the kelp forest from being overrun by sea urchins. And so this is a fantastic little story. And what we find out is that either via oil spills or via trapping or over hunting, that the sea otters can be eliminated from the system. And oh no, that's terrible. And when they're eliminated, unbeknownst to those involved in that activity, these sea urchins can really boom in their population size. And when they do, they can just completely destroy massive tracts of kelp forest. So we see diversity being maintained by sea otters, controlling urchins, and keeping the kelp forest and structure there, which holds all the host of species that exist.